Good morning, and thank you for joining today's webinar from Spec Innovations, Leading the Digital Transformation with Innoslate. My name is Liz Steiner, and I will be the moderator for today's webinar. First, I'd like to go over some quick housekeeping. During the presentation, feel free to send us questions, and we will get them answered in the Q&A part of the webinar. You can also interact with us on LinkedIn through the Innoslate users group or through Twitter using the handle @SpecInnovations. The webinar is being recorded and will be made available to you after the live presentation, so keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Spec Innovations President and Founder, Dr. Stephen Dam. Dr. Dam has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. He has also received an Expert Systems Engineering Professional certification from INCOSE. He is currently applying the systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send him any questions through the LinkedIn user group or send him an email to stephen.dam@specinnovations.com. And now I'll hand over the controls to Dr. Dam and we will get started.
So I'm going to talk about give you an overview of what I see digital transformation being, and then talk about some of the detailed things that you need in that transformation to make it acceptable to the overall culture of the organization. And I think that's a key part of this discussion is how can we make this available for everybody in the organization to use effectively? And that's important because, in fact, that's the definition. So if you do Google, and in fact, the Google AI has a couple of the ones. I did a couple quick looks. What's digital transformation? Because it's funny how many times you go and read all these documents and websites and things, and they don't have the definitions. So here's a couple good ones, I think. And the key is about the idea of using digital technologies to change how you do business. And that means that it's the operations, the processes, the culture, that customer interactions, all those things are part of this. And so we want to make sure that we understand how those are going to impact all these people. And that requires a technique called change management and understanding that change and how that's going to affect people's work, because they're used to doing things a certain way and it's working for them at the time. They often don't see the need to move to these new digital tools to do what they're doing. Doesn't matter if eventually it'll be faster, better, cheaper. They don't necessarily see that. So this is why in any of these kinds of transitions, you need to have sort of a top-down kind of look at them. This has been true since the days of total quality management back in or statistical process control back in the 50s. So these are the things that people have realized for a long time. So you see a lot of top down here, and particularly Department of Defense has been very involved in this as well. And they identified some key technologies that we ought to be looking at to make sure. But the key is here, again, changing how you operate means changing the culture, which is very, very difficult. So we have to recognize that that's going to be a problem, and it's going to take time to get people on board with where we want to go. But we also have to give them really good new technologies and good reasons to do it. Okay, so the key technologies identified in that definition from DoD were cloud computing, artificial intelligence, big data analytics, and cybersecurity. Now, you know, the funny part is on cloud computing, the commercial world transferred to cloud computing over a decade ago. I mean, almost everything you use today on a commercial basis is a cloud app, right? You bank on the cloud app, you shop on the cloud app, you do everything on cloud apps, right? DoD has been very slow to adopt that technology, as well as AI even, over the years, and many other technologies. They just are very, very slow to do it because security is a major concern. And of course, cybersecurity is a key component of the technologies, they say. But again, our cybersecurity is still a little more hit and miss than I think most people want it to be. So again, this is another part of the more systematic approach we need to apply to these technologies to make sure that they can be properly used and effective. So what's what's holding them back? What's really kind of the problem that really they're trying to deal with? Well, the problem can be really traced back to the legacy software and policies. So if you look at a lot of what's out there and what people are doing, they're trying to integrate a number of tools. So I believe this is Arizona State University, is it University of Arizona? I'll get them confused. And they have this idea of a digital engineering factory. And this is not unusual. This is not uncommon. I just use this as an exemplar of the kind of thing people are trying to do. They're trying to take all these tools, most of which are desktop tools, by the way, even the ones that say they're like Teamwork Cloud. What Teamwork Cloud is simply a cloud database where you can check in and check out the database, but you do all the actual operations on your local laptop. And then you recheck it back in. So of course, that means that while you've checked it out, nobody else can do anything to that database. Now, that's not a good way to work if you've got hundreds of modelers, which on many of the projects I've worked on over the years, we've had hundreds of modelers. And integrating those databases afterwards or having to do it sequentially like that would have taken forever and made it very, very difficult and completely ruins the need for that. Again, so you look a lot of it, and a lot of these things are overlapping too in terms of functionality. So this is another part of that. And then GitLab is a very nice software tool, and the software community is very used to using it. But that's not a general purpose tool for everybody in your organization to use. Do you really want your HR department using GitLab? I mean, does that really make any sense to anybody? So this is part of the problem we have is there's this kind of sunk cost in the tools that the people have and they've been using, and particularly if software is driving it, they're going to want GitLab. If systems engineering is driving it, maybe they want Cameo. Maybe it's the test community using TestRail. SolidWorks is the CAD tool. Okay, of course, there are many CAD tools, right? There's a lot of good CAD tools out there. And on and on and on. So you think about this. This is really kind of a very difficult way to do it. And they've got this Violet Labs thing that's quote unquote, bringing it together. But what does that mean? Does that mean is the data residing in these different tools? Is it being duplicated? If that's the case, then I've got a big problem for configuration management. How do I make sure everything's in sync? Well, they'll say the Violet Labs does that for you. But is that really the best way to do it? And so we've got to think about what we're doing and also the cost. By the way, add up the cost of all those things. How much do you think that's going to cost you? I'll bet you that's like $30,000 easily, okay, with all that set of tools. So very, very, very expensive approach to doing this problem. But more importantly is your time. How much time are you taking moving data between these tools? It's not all automatic. So this is fascinating to me that this is the approach people are taking. So what's needed? Again, the idea is to capture accurately the information we need to describe the system and manage the project, right? I mean, that's particularly what we're trying to get done, particularly at the systems and program level. We're trying to make sure everything kind of fits together and works. To do that, you need to create documents. I'm sorry, we need documents because that's what we're doing. We're documenting what the system is. If you can't document it in some way, it makes it very hard. Now, can I document it in a model? Well, yes, if everybody can understand the model, but not everybody can necessarily. Do you want to spend people spending weeks and weeks to learn a particular language that they have to everybody know? Does that really work well? Your people are busy doing other things. Don't give them some kind of obscure language to, and that may be just one tool. You know, on a previous diagram, right? We got SysMLv2 in there in the middle of it. Is everybody going to learn SysMLv2? Do they need to? Why would they want to? Again, if that's your language basis, you've got a problem here. Okay, so going back to this one. So the current tools and deployment strategies really make this very, very difficult. The slide here on the right is a picture I captured at a briefing by the DTO, the Digital Transformation Office out of the Air Force. And you can see how cumbersome that looks. And many different cloud platforms in there. I'm not sure you can read it very well, but lots of different pieces of it that trying to tie together. Again, where's the information? How's this going to be dealt with? It's very confusing and it's very expensive. Again, a way of doing things. So what can we do? What is a better approach? So what we ended up doing at Spec Innovations, and we started this project back in 2011, 2010, 2011, when we got the idea that we needed to do something different. We saw what was going on and where everybody was going with trying to bring together these different tools to make them work together. And there were many vendors providing the glue codes to it, allowing you to move data between them and things like that to become a hub, like we just saw with Violet Labs example. But we found that really wasn't what we wanted to do. We wanted to integrate the functionality of those different tools into a single platform that gives us the ability to do the job we need to do in systems engineering and program management, okay? So we focused on that layer of it because we saw that the design engineering tools that were out there were very, very good, okay? You can go and pick up, I'll use the ANSYS tool set, for example. That's an incredibly powerful set of design engineering tools. You're at that deeper level of the design engineering. However, remember, it takes a long time to run those tools to get the numbers you're looking for. So at the systems and program level, I need to be much faster. And so I got to think about how do I tie this information together in a more coherent way. So that's what we did with Innoslate, is we've tried to do that and create an ecosystem that can be used by all parts of the organization. Now, we do have people, I know I've done training for people in business departments. One of our commercial customers says their HR department's using it. How are they using it? They're modeling processes with it. So again, if it's usable for that community for what they're trying to do, then that makes it a pretty good tool across your entire culture. And that's what we're looking for. And part of that is we created a more modern way to interact. Again, it's a more cloud native organization and approach to it. So again, if you're used to using Google, and almost everybody in the universe now is, then this will be very comfortable and very easy way to get it. And we can provide dashboards and things like that to help you navigate and guide people through your project, through the information set, so they can get the things they need to do their job. They can also set up their own dashboards to do exactly what they want as well. So it really makes a big difference on how you present the information and trace it into forms people understand, okay? And that's the key to doing this. Now, you got to have, the decision makers don't have time to sit there and learn new languages, learn esoterics about modeling, all that kind of stuff. They're looking for, okay, what's the information I need to make the decision? I got to know the cost. I got to know the schedule. I've got to know the performance that I'm going to get out of that I'm going to decide, and risk. Those are the 4 parameters you can almost always count on, right? A decision maker looking for. It may be only one of those 4 they're looking at specifically at a particular decision, but that's the data set that particularly everything else needs to feed into. So once you do that, then you can really start getting greater acceptance. And also the nice part about this is you can lower your lifecycle costs for your entire enterprise in the tool infrastructure. So here's that functionality that we have in Innoslate today. I mean, you have the ability to create documents, things that look like documents. They're not documents, really. I mean, if you think about them, they're actually just data elements put together, and they're traceable and reusable and all that kind of stuff, good stuff. And then we have a requirements view that brings in that quality checker. So now I have an AI aid to help me to determine the quality of my requirements. Great. And in our next release, by the way, we're going to talk about next month, we have all kinds of new things to help you in that area. The modeling. Okay, modeling is, most people feel modeling is a set of diagrams. And you know, the SysML community has always pushed the 9 diagram types they have, which are fine. Before that, IDEF had 15 or 16, I forget how many total, diagram types. Okay, that's good. But is that even enough? Can I possibly diagram my way out of this problem? I've got lots of information. I'm going to view it in lots of different ways that I want to see it. So diagrams aren't necessarily the best way to do that with all of them. Documents might be better. A spreadsheet form might be better. Database view might be better. Again, you use the view that makes most sense for what you're trying to do. Now, of course, in our modeling, we have, of course, all the 9 SysML diagram types. So SysML isn't a bad thing by itself, for sure. It has its capabilities, it has its use, it has its constituency. Wonderful. But it has to interoperate with all these other things. And so if you find, we have the 26 diagram types and 5 charts. And some of those charts are things like your schedule chart, which is your timeline diagram, Kanban boards, things like that. So we have lots of different views and viewpoints that helps you understand the information and work with it. We also have some very nice design engineering integrations. So we have the ability to bring data in from design engineering tools and use it and curate it so that now we can take it that next level. So particularly for, as we get into simulation, we want to have the ability, we have both discrete event and Monte Carlo simulation. You want both, by the way. Most of the processes we have are not deterministic. If you don't realize that, you're not dealing with humans, or you're not modeling probably correctly, because almost everything these days is non-deterministic and stochastic, or we just don't have enough information to be able to deal with it any other way. Okay, so that's simulation, and those simulations we want to run at real time or faster than real time, right? At the systems to up the mission level, we're trying to make sure we know what's happening in over days, weeks, months, sometimes years, even depending on what you're doing. I know we did a simulation for a facility where they wanted to know how much product did they need to produce over. They had to produce a certain number of things over a 10-year period. Okay, that's a long time to do the simulation. I'm not going to take those detailed design engineering integration, numbers and bring them up to that level. I'm going to take the results from that work, which often is presented as a graph or which of course you could then turn into a formula fairly easily, or even a lookup table. So those are the kinds of things you're getting and you're using as inputs to that higher level simulation. Okay, remember, it takes hours and hours to get those data points off of that would represent seconds or milliseconds even in the real time simulation. So again, you can't wait for that to happen. So co-simulation between design engineering integrations and the systems to mission level simulations doesn't make a lot of sense that way. Okay, so be very careful about actually tying the tools together. We want to tie the information together. Also be able to do full V&V simulation as part of V&V. So we have a test center for that, capturing that information and working with it, and it's very powerful. It really helps you understand what's going on and tracking it and relating it back to the requirements. So it's all, again, tied together cleanly, all in one place. I already mentioned dashboards. We have, of course, for the program management side, not only the time, but we also have schedule, we have cost in the work breakdown structures, cost elements, and also risk. So we have the risk analysis. So you could do risk matrices, risk burn down charts, things like that. So to get all that capability is in one place. So this makes it so much easier for you to work with, and all the information is in one database. It's easy to work at and scalable. because it's cloud native. So you can scale to very, very large numbers. We've tested it to 10 million objects and 500 simultaneous users. So you can see that gives you that strong basis for that transformative digital tools ecosystem you're looking for. Now, of course, it can't do everything by itself. Again, already we're talking about design engineering integrations. So let's show some of those. So these are the ones we have done ourselves that we found, frankly, provide sufficiency to what we need to do this. But again, you may have different tools you want to use, and we'll talk about how that integration could happen. So one of the problems you run into is, again, a lot of the tools out there are still fundamentally desktop tools. So STK just came out with a cloud version. We haven't done that integration yet. But we're going to do that as soon as we can. MATLAB, of course, is a very wonderful tool, very capable, but again, it's a desktop tool. So we had to create a Java web app to interface between Innoslate, which is cloud native, and these desktop tools, because it's got to know how to get the information to the place on your computer, right? So you've got to be able to make those connections. So we've been able to do that successfully. And again, if I've got a MATLAB model, I don't want to take the model and put all the model information in Innoslate. That's not what I'm going to do. I'm going to run that model here concurrently with it. Okay. So now the data, all I need is to say, well, what am I looking for? Pass the information from Innoslate to MATLAB, and then take the information back to MATLAB. Similarly with STK. Again, these are the things that help me put constraints of more detailed models and geospatial information on that mission level, systems and mission level models. So that's a good example. The ANSYS tool suite, we realized SneakerNet was best. Okay, it's a matter of curating the information in Innoslate, not interoperating directly. That doesn't make any sense from a time perspective. Okay. What does make a lot of sense, by the way, and we use it internally, is GitHub integration and Selenium for our software development. So all our requirements are built in Innoslate. We pass them to GitHub, which they call them issues, and so we can monitor that work and activities. But as those issues are updated and are resolved, they basically then that status gets updated in Innoslate automatically. So again, we've created the webhooks between those two tools to do that. Web-based tools make that very, very easy. Selenium, similarly, we've done the same thing with Selenium and JUnit and having them work together on the V&V side. So we have 11,000 or more now automated tests. Now, to do those to manually track those was very cumbersome. Took a long time to go through the process. We now automatically update our test center test sheet, and as each test cycle is run, it's run simultaneously with Selenium. So now there's no time lag or time difference for it. Again, so we took something that was days to hours. And so that's a big, big part of this digital transformation we're trying to do, right? We're trying to make sure that when we do V&V of our software, it's as quick as we can make it, because we want to turn around and get the application out, but we want to get it out well. We want to make sure it's well tested. I briefly mentioned CAD before. The CAD interface is simply a viewer. All we want to do again is curate those files and be able to view them and understand what's in the CAD file, and so that you can do the more detailed work in the CAD tool you need to work in. Okay, and that works with just about any CAD tool. They have the formats that we have for that viewer. So again, that's great. Another thing we've worked hard on is this secure generative AI. So we have open AI that we're working with right now. It's an open platform on the open cloud, but there's a lot of security concerns with that. A lot of people are worrying about their IP being put out on the internet or being reused, and totally concur with that. So we've been working with a company called Ask Sage, and they have an ability to put the AI behind the firewall and use those different AI techniques. So that's coming here really, really soon with the 4.11 release. But our key goals of integration here are make sure we keep the data use between the tools, keep the data where you can, minimize that data duplication wherever possible. Again, this is the concept of a data mesh, where the data is residing in some place, and you're just connecting with it and working with the data where it needs to be. Oh, I forgot to mention the HoloLens. We are native with the HoloLens because we're cloud native, and it's a web browser-based approach. You can just go use it. So if you want to do AR, VR, you've got a mechanism for doing that right away. So I think I hit everything on this. What makes this possible, again, is that architecture we have. So we run a SQL database at the lower layer. And so there's a database server, or again, virtualized set of servers that you could do for the database storage. That works very nicely. We have found a lot of people ask, well, why aren't you using the new technology of graph databases? And that's okay. We actually started with a graph database with Google Bigtable. That's where we first were. But we found that there wasn't a big advantage to using that over a SQL database because we use two-way relationships. And when you use just a one-way relationship, that's not as helpful for that. It doesn't give you that speed, extra speed and scalability that the graph databases do. So since two-way relationships are critical to systems engineering and project management, because we have to have traceability, right? We'll be able to trace it from top down to bottom up. And so we have to have that. So that's why we use SQL. Then we have a Java core, which again runs on a different cloud server. And so those run and interact with each other. And then for the interface, we have our UIs are all written in JavaScript. And they use the REST APIs to interact with that. So the nice part about that, if you want to build your own plugin, okay, it's easy. You just take our REST APIs and work with it. And so you're good to go. And so again, and those are stable because we use those same REST APIs. So now you don't have to worry all the time, well, they're going to deprecate those APIs. No, that doesn't going to happen. The other thing we've worked very hard is security. Lots of security factors. We are probably the most secure platform out there. I hope we are. I want to be the most secure platform out there. We've worked very hard on that, and we do all the work in the US here with a very small team, co-located. So we don't have a lot of problems with that kind of, making sure the code is well handled and well adjusted. So anyway, we're currently on a variety of different servers in classified environments, DoD and DOE, many other organizations. So they're all using it in a very secure environment. So that's the key. But so again, you can do this and really help your cybersecurity, your data access, and information exchange. So let me dig deeper on a couple of these items that we talked about. Hybrid documents. I mentioned this before already, but it's important to recognize that documentation is a key part of what we do in systems engineering and program management. We aren't just coming up with a design. We're documenting that design so people can see it and understand it and evolve with it over time. You always want to be able to come back and when something's not working right, well, what happened? How do I trace back to where the problem was? If I don't have some level of documentation, I can't do that. So I have to have that and that traceability back. Now, so that drive that's been going on between document-based systems engineering, which again is working off of what is effectively a paper kind of approach, which now we're of course using things like Microsoft Office and PDF and things like that, which are wonderful documentation tools, by the way, absolutely fabulous publication tools, but they're not good for what we're trying to do here with the databasing. So again, this move to model-based was let's throw out the document forms. No, let's use the document form with the model information, okay? And now you can have the best of both worlds. And that's what we're always looking for, is how do we optimize the situation using the good proper form everybody can understand. I mean, everybody reads the document, everybody reads books. That's how we read. So that's very comfortable to everybody. So that's a great place to start. So by using our generative-based tool to generate the document in that form, the elements are reusable and traceable. And that's the key. So we have not only a documents view, we have a compilation view that we added as well. What we found was we have, in the documents view, we use statements and requirements as the data elements that make up that. And of course, those are contained within an artifact as the container. So what we found was that people were putting a lot of information into their models. So they actually built a model and they wanted to be able to express that model in a simple form. Well, here you go, compilations view. So it lets you reuse all that information you've built at in this. And so in fact, this is I believe coming from that. So you document you're using. Again, we reuse all the diagrams and things like that are all live, so you can update them. We have baselining, all the other things that we need for configuration control, which I'm going to talk about in a minute more. Again, traceability. Traceability is not just 2 dimensions. You know, almost every tool has a 2-dimensional table kind of thing that they use for this, but in reality, it's n-dimensional. All the relationships between the information, again, have to be bidirectionally created. And the language we use is the lifecycle modeling language, gives us those relationships as well as the basic information elements we need to capture in one coherent way. So we've extended that here and there where appropriate, but for the most part, we use pretty much that language straight out of the box. Of course, again, the access to the information must be controlled. So we have ways to control the information, who can see what, and a variety of different ways of doing that, which I think I'm going to talk about a little bit more. Yeah, a little bit later. So role-based access. So again, everybody has their role. We have defined 4 roles, specifically an owner, a collaborator, a viewer, and viewer. The owner can do anything in the project. The collaborator can do a lot in the project, read and write, but they can't, add new users, for example. So things like that. The reviewer can see everything, can create reports even, and they can leave comments, and they can suggest changes. And then a viewer, well, the viewer can just view it. They can create reports out of it, but primarily the purpose of viewers, you don't want them changing anything. So again, those are simple ones. You can extend those. You can add to those as you need to. For example, like a configuration manager, you may want to have them be able to do the baselining and the workflow. So again, you give them those privileges to let them do those things specifically. Again, so the access controls give you, it have to be easy enough that they're going to be used. This is one of the tricky parts about this. If you try to do that at the data level, it's almost impossible. You're not going to use it. People are not going to get to each little data element item is just not going to be done that way. So what we found was by creating projects and let people have their own projects and be able to share the data between the projects, they can determine how best to share what they want of the information set that they have. So it's a set of data you're sharing back and forth rather than at the individual data level. We find that that's a little bit more easy for people to use and work with than trying to do it at the individual data element level. Model-based reviews. So we've been doing this for actually quite a while. The first one I remember hearing about somebody using the Innoslate to do a model-based review was back about 7 years ago. So for a set of NASA reviews. So you really are going to have to go change the culture about the review process. We've made this available many times to customers and had them say, well, yeah, we want to do model-based reviews, but we're not ready for that yet. So again, there's going to be that changing the culture and getting them comfortable with it. And again, we think we can show them how to do that fairly easily. There are a number of people who are using Innoslate for that purpose, and having that ability to provide the dashboards and be able to work with it. The top right thing I'm showing you, in fact, is something we took to a show. It was AUVSI had a demonstration that we were doing, and we actually created different, for each company, you see that that second panel, column panel there, the different companies that had their own database even. So they could go click on that and go directly to it, or they go directly to their own if they wanted, through other mechanisms. But then we captured the information as we went through and bring it all together in one place. We had different assessors having their own projects that they could have their own tracking with it. And again, those get rolled up into the master databases as well. So again, there are lots of ways to do this and make it really work well for people. We had people who had never seen the tool using it that day. So again, it works. Enhanced collaboration. So collaboration, again, was one of the big drivers for us for even developing Innoslate. We really needed the ability to be able to track and see who was working on and have everybody work on it simultaneously. Again, that cloud computing technology enables that, but the tool has to be cloud native. It's not a cloud storage, just cloud storage device. So you have to actually interact with it. And now control can come from blocking and workflow. So you can add control to that data flow. But fundamentally, I want everybody to be access the information in the project I'm working on. Again, you can separate out separate projects, and within an Innoslate organization, you can share the data between them. So it's very exciting, and it works very well in these kinds of things. So we have those real-time indicators you're seeing here, where the user's accessing the entity, or there they are. I know who it is. It's on there, that little indicator. And again, if you're looking at that, and you can be looking at that entity in any other view, it doesn't matter what you're looking at it in, it'll pick up that someone's looking at that, and you can track who that is and help them with it. So again, those indicators really help with that collaboration. Best practices of user stories. So we've collected a lot of that in our resources page. So if you go to specinnovations.com and go to that resources page, there's tremendous amount of material there. Oh my gosh, I can't tell you how much stuff. There's free ebooks, even for one for kids. Okay, I mean, we've literally taught using this tool at the 4th grade level. Okay, that's usable by anybody. Okay, I think we all agree we all can deal with it, stuff at least at the 4th grade level. So we don't probably have anybody who'd have a problem using it there. Anyway, more resources. By the way, there's a digital curation station. That's where we've parsed many documents. We have some models and things in there, and of course the government reference architectures. That's kind of a big thing these days. We've been taking and translating those into Innoslate for some time now, and we actually have some that aren't listed there that we can't share directly unless you're a U.S. citizen. So again, we're going to keep that going and provide that service to make sure that people can have alternatives to the current tool sets they're using. Okay, so we really don't have time to show you anything. So if you're interested, contact our salespeople at sales@innoslate.com, and also contact us. So I guess we've got time for questions. Do we have any questions yet, Taylor or Liz?
Thanks, Dr. Dam. We've already received a few questions. If you haven't done so, please send your questions to the panel on the right that pops up after clicking Q&A on the top bar. Our first question is, you cover the interconnectivity of the web-based version of Innoslate. However, we use the enterprise version on disconnected networks because of security needs. What can we use from an integration perspective along the lines of your presentation?
Sure. So in fact, we did design it so you could deal with that problem, because of course we deal with that problem all the time. The idea is that each project can be imported and exported in the format, XML format, or the XML plus anything you've uploaded. So that's our .ino format. It's a zip format, so you can easily move that as you need to between things. Particularly, another thing you can do is do branching and forking. So for example, let's say I want to I have to go deploy, and I've got to go out to the field, and I want to put Innoslate on a laptop. I'll take my database, export it, branch it, and then take that and import that into on the laptop. And then when I make the changes there, I come back and I re-merge it back in the branch. So now I've got that integration with it too. So again, a number of different mechanisms like that. Also, of course, we do have a round trip with CSV. So let's say you don't want to have to get them too involved in the mechanics of Innoslate. You can have them simply create a CSV export. Make sure you keep our user universal IDs in there. But if you do that and you give it to them as a table, they can update the data in the table. Just give them the instructions how to do that, and then that can be re-imported into Innoslate to update that information. So several different ways to do that in that environment, and all our features work together in the enterprise as well. So if you even set up your multiple projects within an organization, an Innoslate organization on your enterprise version, you have that same data sharing options as well. So yeah, no, we care a lot about that situation. Next slide, question.
All right, next question is, what features in Innoslate are most effective for breaking down silos in large multidisciplinary teams?
So I think that's the beauty of it, is that many of the teams are doing different pieces of it. I've seen people break up the problem into like requirements and the modeling and the tests as being separate things, and then integrating them together is really, really hard. So that's one way that you can improve that. The other is we've seen how to use systems engineering, I think, what I call appropriately. In other words, our job as systems engineers is to define trade studies. It's not to do the trade studies. It's to define trade studies the design engineers should go off and do. Okay. And then I want to take the results of those trade studies and curate them back. Things like that. Decisions are another class of information. We want to capture decisions that are made. So again, back at the other level, I'm taking presentations to my management. They're making decisions. I want to capture those decisions and all the information associated with them, so we know why the decision was made. Invariably, it was made for a good reason at that time. 6 months downstream, you realize you need to make a different decision. And to know the why behind the decision at the beginning really helps you make a much better decision in the future. So you're not replowing old ground. So these are some of the features we have that make that a little bit easier. Hope that answered the question.
Thank you. Our next question is, can you please highlight the as-is to be modeling options?
Oh, okay. So basically, again, you can set those up as separate projects if you want, and then share as you appropriately between them, or again, branch and fork is another option for that. You start with your as-is model and then branch it to fork to become to your 2B and be working with that in that separate project. Again, merge them back together if you need to later on downstream. You can also simply label the different components that way and see it. So again, just a lot of different ways to do it in Innoslate.
Thank you. Our next question is, what are the best practices for integrating Innoslate into existing engineering workflows during a digital transformation?
So a lot of that's modeling your processes that you have. And again, Innoslate can be used to do that. And then understanding what it is you're doing today and making the changes you need to make through that process. We often take policy documents, for example, as a starting point, and we'll go through and modify those, again, using Innoslate. And we treat it like a document, but again, we could take in things like very often in a policy document, a portion of that will be a process. So we'll build a process model for it, make sure the processes work correctly, things like that. So and then bring that back all together in one place. So I think did that answer the question?
I think so. Let us know in the chat or in another Q&A if we're answering your questions, or if you got some more follow-up questions for us.
Mhm.
In the meantime, I'll ask our next question. How is data governance done to prevent simultaneous uses during stale data?
Using stale data? Is that what
Yes,
STAL? Okay.
that is how it's spelled.
Uh, so, so stale data is always a problem. You know, do you have the latest piece of information from where you're supposed to? The only way what since every time you enter a piece of information, we create a date timestamp, so you actually can track each object. And if you update an object, we have a history file, so you track that history of each object as well. So now you can kind of see what's going on, what was changed when. Plus, there's an activity feed on the dashboard, so you see who changed what when. And that's another way to just kind of look for maybe problems where you might have some stale data issues. Um, but ultimately, it does require a certain manual look at the information. We do give you the AI chatbots as an assistant as well. So you can query those to see if there's some newer data someplace. Um, and then, we're always looking at new technologies to see how we can manage and push data and move data around better as well. So always open to that and figuring how to do that better.
Thank you. Our next question is, does Innoslate provide APIs or linkages to other potential agencies, tools such as GEA Navigator?
GA Navigator. I don't know what GA Navigator is, so that's a little hard for me to say that. I think our REST APIs are open and fairly easy to use, as long as, again, it's a cloud kind of based tool. It's usually pretty easy. When you get to the desktop tools is where we usually have trouble. But again, a CSV import export works very well almost between any set of tools, I will tell you. And since we auto generate all our diagrams and things like that, information from it, the views from the data, all we need is the data. We don't need positioning. We don't need all the other information that's often that people push. It's better to at least get the fundamental data set right and make sure that's concurrent. So that's how I'd approach that.
Thank you. What are some anticipated AI features you are planning on implementing, and how can I use them behind safe and secure firewall?
So definitely a couple of the interesting ones we're doing were fairly easy to do. In fact, you can be able to generate risks, and so that's always an important capability. Is how do I track my risks? How do I generate risks from something like a requirement, and understand what my risks are? And the generative AI is very good for that because it can look out and see what's been done in the past. And so you can kind of use that history to help you understand and look for those kind of problems. Another is test cases. You can do the same kind of thing there. It can create test cases for you from the requirements directly. We've also done some very interesting things with document translation. That you can actually translate down documents from one language to another. And of course, we have the general chat bots as well. I forget, there's like several other features that are coming in with that will be exciting for it. So do look for that here coming very, very soon. Now the security part of it, again, we are looking at options, particularly Ask Sage is one we're working with currently. That's the one that we know is getting approved at IL 5, and they're working on IL 6. So we think that's a good way to go. We actually think the company that's doing this is a very well known, led by a very well known person, and so I think you'll find that that's certainly a good way to do it. We are looking at other options as well, of course. Of course, once you put it behind your own firewall, you have the decision whether to use it or not. By the way, the enterprise version, or actually any organization, will have the ability to turn it on or turn it off, and add your own keys. And so you have a number of different ways that you can help improve that and access the information and use the AI features. We do think AI is a really, really important new technology that we are certainly embracing. We've been researching now for at least 4 years. So it's now time to get it in the tools and work in using it. Any other questions?
Yeah, we have a couple more questions. We have a follow-up question from the previous question on the stale data.
Okay.
Can you clarify what you mean by curate the data?
So curation is usually when it happens when someone runs another code or something like that. Let's say a finite element analysis, and you get the results from that. And you probably want to have all the setup files or anything else you use to do that. You can upload any artifact into Innoslate, and so that could be any file type. So now that allows me to document, what was that run, what were the results, take the results and tie that together, and document that information. So that's the curation part of this. And so by doing that, then I can have a better idea of, when this was done, who did it, what were the results, and what's the benefit of those results. And so having that ability to document all that in one place and be able to link it to the files that were used in that process it just makes life so much easier. Too often what people do is they have the files sitting there in a folder on their desktop or their SharePoint or some other place, and it's hard to find. This gives you a way to go search and find the information because you documented it in the description field correctly, and all that information is right there for you to download and use.
Thanks, Dr. Dan. We have one more question. Is it possible to import PDF documents into Innoslate? Most of our documents are in PDF format. We would need a reliable and robust process to import them. Any guidance you can provide will be helpful.
Sure. So it's actually, if you get a full version of Adobe Acrobat, it will let you save the PDF as a Word document. Then you can use our Word importer, and it does a very nice job of bringing in everything, pictures, tables, you name it. It's a very good way. It does require you to make sure the style headings were used to do this. So that's how we detect parent and child relationships. So that now we can break up the information into different data objects as you need them. But we can certainly help you do that. We also provide a service for data migration. So if you do need help with that, we certainly can provide that. We've done that for a number of customers.
Perfect, thank you. That looks like all the questions we have for today. We would like to thank you again for joining us today. As a reminder, we will be following up with you very soon to send you a link to the recording and the presentation slide deck. We hope you can join us for next month's webinar, Innoslate 4.11 update, on Tuesday, February 18th. Your link to the sign up will be in the email that is coming soon to your mailbox with the slides and recording. We also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Have a wonderful day, and we hope to see you at our next webinar.